In this unit, we're going to take a look at the retirement problem, where we're going to combine some of the concepts that we know and that we have learned, but we're also going to take a look at how to use the solver. If you haven't taken a look at the problem yet, feel free to pause the video and then resume the video when you read the problem here on the right. So we have an individual in this particular case that's going to put away $48,000 per year, and then I'm going to withdraw $30,000 per year after 5 years of deposits. They're going to start depositing right away. So we're going to do equal 48,000, okay, starting in year 1. Absolute reference. Control C, shift, hold it down, and press down arrow through year 5. After that, they're going to withdraw the money. So equal negative, and grab the 30,000. F4, enter. Control C, shift, hold it down, go down through C19. The account balance at the beginning of the year is just 0. But the interest that's earned during the year, since the deposits are made at the beginning of the year, are going to be on both the account balance at the beginning of the year and the deposit at the beginning of the year. So I'm going to open the parentheses. I'm going to grab the account balance plus the deposit at the beginning of the year, and I'm going to multiply it by the interest rate of 8%. F4. So then the total in the account at the end of the year, I'm just going to sum up B7 through D7. Okay? So at the end of the year, we will have whatever we started out with plus the deposit plus the interest earned. Next year, we're going to start out with whatever was in the account at the end of the year. Okay? Now I can go ahead and copy these down, Control C, shift all the way down. Okay, and then Control C, shift all the way down. Okay, if something did not work out in this case, you have to check your absolute references. Okay. So now at the end of the year, this was the first problem. How much will they have at the end of year 13? Well, it's 218,000. Well, what if we amend the problem? What if we say, how much do they need to deposit per year in order to have nothing left at the end of year 13? Well, in this particular case, it's pretty obvious that if they want to have nothing at the end of year 13, they need to deposit less money, right? Not 48,000. So how do we actually figure out this what should be this annual deposit? So the key thing is that we have to have everything referenced correctly here. So I have all of the cells from C7 through C11 reference to cell B3. And now what I'm going to do is use the solver. So if you don't have a solver installed, and the way you find the solver is you go to data, and here's the solver right here. So if you don't have the solver installed, take a moment to actually install it. Pause the video and go to File, Options, Add-ins, Manage Excel Add-ins, and click on Solver. Once you have this installed and you have it popped up here, we're gonna be able to use it. So let's go ahead and click on the solver and let's see what that's all about. So in this particular case, we're gonna give solver a couple parameters. It wants us to set the objective. What is the objective? Well, the objective is to have this cell right here, 218, equal to 0. Right? So we're going to set objective this cell value of 0 by changing the which cell 48,000, right? Because all of these are referenced to B3. I'm just going to go ahead and press solve. Okay. And then it gives me a solution. Do I want to keep solve a solution? Yes. So this is going to be the annual deposit that's required to have enough to withdraw 30,000 a year for 8 years and have nothing left in at the end of year 13. Is there any other way to do this? Yes. So let's first take a look at how these deposits and withdrawals look like. So we found that we need an annual deposit of 29,000 to have the withdrawals of 30,000 for 8 years. How does that look on the timeline? So here we have 8 withdrawals of 30,000. Here we're going to have 5 deposits of 29,000. The future value of these deposits has to equal the present value of the withdrawals to have enough. And that's exactly what happens here, right? I actually calculated this out already. And you can see here that the future value of the deposits at 29,000 exactly equals the present value of the withdrawals. Okay. I don't know why it says at the end of year 3. Okay. So now let's take a look at if we can actually solve this by formulas and functions rather than using a solver. So one way that we can do this, we can discount all of these withdrawals back to present, and based on that amount, figure out what the deposits should be, right? So let's do that. So let's get the present value of the withdrawals. It's going to be a 2-step. First, we need to get the present value of the annuity of the withdrawals. And then we're going to get this lump sum here. We're going to take it back to present. Okay, we're going to take it back another 5 years and get present value of that. So I'm going to do equal present value. The rate is 8%. Number of period is 8. Payments is 30. Okay. I'm going to close. Actually, I'm going to make it negative 30. Okay, so we have a positive number. I'm going to close the parentheses. This gives me present value of 8 payments of 30,000. Now I'm going to take it back another 5 years, discount it at another 5 years. So I'm just going to divide it by 1 plus 8% to the power of 5 years. Okay. Now I can back out the payment. So I'm just going to do PMT, take 8%, number of periods is 5, right? And the present value is going to be negative present value of the withdrawals. Okay. And as you notice here, it's the same number as we got from the solver. Is there any other way to approach this problem? Yes. We can also find the present value of the 8 years of withdrawals in year 5. Okay? And then it will become a future value in the next part of the solution to this problem, where we're going to figure out what the deposit should be. So let's do that. So we're going to do present value. We're going to do the rates. Number of periods is 8. Payment is going to be a negative 30,000. And we're going to do 1 for the beginning of period, since the withdrawals all start happening in the beginning of the period. So what we got here is the present value of all of these withdrawals that happen over the 8 years. Now let's find the payment. So we make the deposits, and we have to make deposits large enough to have exactly $186,000 in the account. So this becomes a future value, right? We're going to make some deposits, and the future value is going to be 186. So we're going to do PMT. We're going to grab the rate. Number of periods is 5. There's no present value in this case. And the future value, I'm going to put it as negative, so I get positive payment, is 186, right? This is how much we actually need to have an account. Comma, 1, right? 29,386. So you can see that there's different ways of approaching the problem. It's a really good idea to make a timeline, so then you can see what you're working with. You can use a solver to do this, and I would like for you to know how to use a solver, right? How to apply the solver. And there's also a way to do it with present value, future value, and PMT functions.